I saw with you is at CPPCon in like 2015. You did variadic templates. And it's funny, I remember it because I had more hair back then, but I lost a bit of it when I got done with your talk because I didn't do templates. I certainly didn't do variadic templates, but it was a great talk. I really enjoyed it.
Yeah, and that was C++ 2014, so it became a little bit easier today.
Yeah. So tell me a bit about yourself, because I know I've seen you at various conferences, but I've never got to interview with you before. So I appreciate you taking the time this morning.
Okay, who am I? I always wonder where I start. I started studying computer science in 1983. And that was the same year I got my first own computer, which was a Sinclair ZX Spectrum. So I couldn't afford more.
Okay, yeah.
It served me.
I remember the Sinclair.
A little bit during my first year, but later, especially after I earned my first money as a programmer, I got an IBM PC clone. So that one served me throughout my whole university time, which ended in 1989. Then I had a kind of a time travel experience, because I was drafted as a conscript after my university time in 1989 for 15 months. And I was drafted to the programming center of the German Air Force, the Deutsche Luftwaffe. And there I actually was operating and programming on a PDP-11, running Unix version 7-ish. I'm not sure if it was full version 7, but at least it was beyond version 6. And also they had for their radar systems that they were developing software for, they had a used aircraft computer which had 18 bits. Just to have 2 bit more precision. And it actually had a front panel where you could enter the individual bits yourself for the bootloader, for example.
Oh, wow.
So that was a kind of a time travel in 1989, 1990. On the other hand, it was a fun experience. I, as a conscript, was actually teaching all the officers C and Unix, because I was, while still at university, I was working for a training company teaching C and Unix from around 1987. So that's my background. And teaching a programming language, you learn it much deeper than using it yourself only.
Yeah, anything you want to learn, just teach it.
Yeah, that's how long I've been teaching programming to people. I then, after finishing the university and the Bundeswehr, the army at the time, I came to Siemens Corporate Research, where I was doing software engineering research. And the major outcome of that was a book I co-authored with others called Pattern-Oriented Software Architecture, a System of Patterns. So it wasn't the first design patterns book, but it was the first one who put pattern idea into architectural levels. And there are well-known patterns described in there, like layers for layered systems, which is still in use today. We had a pattern called pipes and filters, which we more or less got now with ranges library in C++ as well, directly in the language. So that's kind of the history that I went through. In 1997, I came to Switzerland after projects within Siemens recurred over and over, and it wasn't much to learn new. I actually called Eric Gamma, the author of the Design Patterns book, and asked him to work for him. And then he put me on hold and said, I'll call you back in a couple of weeks. And he called me back, well, I cannot offer you a job, but you can have my job. So that's how I came to Switzerland, taking over the remains of his team in a small Swiss company that we later actually bought out from the owner, and I more or less ran the software engineering part there. Then I had my personal year 2K problem. I was diagnosed with leukemia, which I survived, as you can easily see, and that I lost my hair instantaneously. I might be as bald as I'm today anyway, but that was kind of instantaneous hair loss in 2001, and then I got treated with bone marrow transplant. So,
wow.
So for all of you listening to this, if you aren't a registered bone marrow donor or stem cell donor, go there and become one, because you might actually save someone's life. So that set apart, after recovery, I actually, I was then not working for about 3 years. And in 2004, I joined the University of Applied Sciences in Rapperswil, Switzerland, where I founded the Institute for Software, which I led for 15 years. Until 2019, or actually February 2020, when I quit there for several reasons, especially because the school leadership and the political influence into the university was too much for me to actually wanting to put my head in front of my people. So, and being married to someone who had a very good career helped a lot. So I didn't have to feed anybody. So I was fed by my wife.
That's always helpful.
Since then, I work as a freelance trainer and consultant, and do a lot of voluntary work still with the C++ standardization, but also with standardization of safety guidelines, especially the MISRA C++ guidelines that came out last year in 2023. And also I work on another ISO standard beyond C++, which is called programming language vulnerabilities, and the working group is WG23, and there I work on the C++ vulnerabilities guidelines, and it's all voluntary work. And beyond that, I still do some kind of teaching, which could be a little bit of more, but not too much. So if there's any interest in get taught on let's say C++ and safety, or any software engineering or pattern stuff, I can still give my input to a lot of teams, I think. And during university times, I taught a lot of students C++ and software engineering, and we did a lot of interesting things based on in refactoring of languages, most notably C++ refactoring, which everybody tells you it's impossible. We create a lot of good tooling around Eclipse CDT, which is kind of abandoned now because of me leaving the university and nobody actually picking it up. And also it's kind of, let's say, Eclipse is kind of on the fade out of being supported well. And I know that other companies like Visual Studio Code or JetBrains tried similar things, but it's really hard to keep up with the evolution of C++ and still having good refactoring tooling. So it's I've been there, done that with a lot of help of students and engineers in my institute, but it's very hard to keep up because the language evolves so quickly. And let's say if you have a working refactoring that is non-trivial, you have to check a lot of things, and those checks need to change whenever C++ changes. And that's kind of the mess all of the IDE people are in at the moment, where the language makes it let's say C++ refactoring is at least an order of magnitude harder than doing for Java, for example, where everybody does refactoring, and keeping it up to date is also an order of magnitude harder than with many other languages. And
especially now that we're changing it every 3 years, there's additions to the standards and everything else, right?
There are a lot of things. We had a lot of good stuff around modernizing C++ 03 to 11 and 14. But beyond that, neither the Eclipse CDT parser managed to catch up with the C++ 17, full of C++ 17 and 20, and nor the tooling infrastructure beyond that. And I know that the other vendors also struggle. So if there's anybody listening to this and says, oh yeah, we want better refactoring for C++, yes, but it's expensive. And you still can do a lot of things by hand. So that's also good.
So I wanted to talk with you this morning because you're doing a workshop, and obviously after hearing everything that you've done, you've more than qualified as a teacher. And so if anyone is interested in MISRA and Safer C++ with MISRA, you're giving a workshop Wednesday the 28th. I think it's from like 9 to 17 UTC
Exactly,
for CPP
yeah.
Online, correct?
Yeah, that's
and so
the training. Maybe I summarize a little bit. I'm not teaching the individual rules because for the MISRA rules, you will get a checking tool anyway that tells you all the bad things you've done. My approach is more, let's say, proactive, teaching you how to prevent actually triggering the tooling by writing more modern code or better code so that you actually avoid getting hit by rule violations. That's the goal. I will nevertheless mention some of the MISRA guideline rules and tell you how, let's say, when to actually violate them, because any kind of static analysis tool or checkers will have false positives. And if you're doing safety critical code, regardless, you might actually, some of the rules are written in a way that you have to violate them, but they are written down because we wanted the programmers to actually think before violating a rule. And that thinking part requires a judgment of, yes, I know what I'm doing, and actually argue that you know what you're doing. C and C++, for example, typically expect you to know what you're doing. C was written by the best programmers of their time for themselves. So they knew that they knew what they were doing. And C++ changed that a little bit because introducing a stronger type system by Bjarne and then other things. But nevertheless, it still has the underlying assumption that you will avoid undefined behavior. And it's, let's say, it's very easy if you're not paying full attention 100% of the time, that you easily fall into a trap where you get into undefined behavior land. And the compilers warn about a lot, but they might not warn about that, especially if the undefined behavior is runtime dependent and you just omit a check, like, oh, you try to dereference a pointer and you forget a null pointer check, and that pointer might come in as a parameter, so you have no clue who was actually calling that function and might have passed a null pointer, or otherwise a dangling pointer, which is the one thing that you cannot actually check for. You will not know when you're using a pointer reference if it was dangling or not when it comes from the outside. And that is something where let's say the compiler will not tell you, unless it can prove that it's dangling, it will not tell you that it's dangling because it assumes you're a super programmer who will actually not dangle anything.
Yes. So when you do your classes, how much do you do that is theory based versus, like, do you do much that is actual practical, where the students are actually writing code themselves? And what's your methodology when you teach?
Well, I always show code. Only the code tells the truth is something I actually stated a couple of times at different conferences. I think the first time was around in ACCU around 2007 as a workshop there. Because, let's say, theory helps a lot. I became a much better I much better understood the C++ type system after working with a colleague at the university who was into formal methods, and we ran master seminars on type system theory. And usually that theory is more like, oh yeah, you have bool and nothing else, and then you combine everything. So it's like the universal Turing machine level of type systems. But the interesting part is actually that you don't apply that directly in your C++ code, but it helps you much better to understand what a type system is and how it works. And it made me a much better programmer and explainer of C++.
It's interesting because I was doing C++ in my day job for quite a few years. And then recently I started to have to learn some Go, or I had to get really deep into some JavaScript. And so the way I'm relating this is it made me understand the theory behind more C++ items as I had to learn, different functionality in different languages. And so I can appreciate your point on the theory just gives you that greater depth. But, also like you're saying, whenever you got to teach something, you definitely pick up a lot more that way too. So what's your favorite part about the class that you're looking at teaching?
The favorite part is that actually some of the MISRA guidelines were heavily influenced by my thinking and teaching in the past. So just one example, if you design your own class type in C++, there are a whole bunch of special member functions that you either get from the compiler automatically, or that you might want to deal with them yourself. And well, those who do C++ seriously from the old times might remember the Scott Myers rule of 3. Yes. It was stating, okay, if you have to care about either destructor, a copy constructor, or a copy assignment operator, you usually need to care about all 3 of those. That was kind of a hand-wavy thing. If you just hear that saying, well, Scott Myers in his book goes much deeper, but if you just hear that, you scratch your head and you lose your hair, and you end up with the situation, I need to care about them, but how? And for example, I've seen code bases, for example, of the Ingenuity Mars helicopter. Actually, it's written in C++, and I was looking at the source code, and it has a lot of class types where there is a destructor defined with an empty body and nothing else. So defining a destructor with an empty body is some of the pieces of code where I say that's completely redundant. So if your classes have an empty destructor defined, just delete those definitions. Especially since C++11, such an empty destructor has influence on triviality aspects of your class type, and also on possible movability of your class type. So there was a talk by Howard Hinand, I think I forgot the year. It's cited in my slides. So where he describes a table of all the possible copy constructor, copy assignment, move constructor, move assignment, destructor and default constructor, and how each of those, if you define it yourself, influences all the others. And memorizing that table in the top of your head is something even I cannot hold in my head completely without looking it up. And so the MISRA guidelines and my teaching actually has a guideline to when to actually define a destructor and when not to define any special member functions. So that's called today the rule of 0. So write your class types in a way that you don't have to define any special copy constructor, move or copy or move operation or destructor. Then the compiler so that the compiler provided ones are perfectly working. Yes, and
I gotcha.
There are just a few cases where you need to define a destructor, and if you want to learn those and all the implications, like I want a type that manages the resource, then you need to care about cleaning up the resource. So you need a destructor, and there are different styles on how to create such a class type. Depending on how powerful that is. For example, if you consider standard unique pointer is a class type that is move only, so it it needs to define some move operation and a destructor, but needs to make sure it isn't copyable. And how to do that for your own types and when to do it is part of the teaching, and it's also part of the MISRA rules that we defined for C++ 17. So that's something I'm very proud of that went into MISRA.
And the detail in that, I have to say, like, I know that if I'd taken your class, my C++ would probably be infinitely safer.
Well,
so, because some of the things... Well,
it's not only about safer, it's just better. So my company has, my own company has a subtitle, Better Software, and that's my lifetime goal.
Yes, to rid the world of bad software. I remember that quote from your NCD Tech Town talk. Well, if anyone else would love to get a hold of your experience and enjoy a great class again on Wednesday, February 28th, sign up at CPP Online and take Peter's class. And if you haven't signed up for the conference yet, make sure you do that too. Peter, I appreciate you taking time with me this morning on my side of the planet, evening on yours, I guess. And yeah, I thank you very much.
Okay.
I will see you online at the conference.
Definitely.